This assessment asks us how many unique signals we would have for hydrogens in a spectrum for the molecules shown. Now, complicating this question is the fact that this pyridine ring can undergo resonance or has another resonance structure that I've shown here. Why I bring this up is because even if when you look at this ring you don't see symmetry because of the locations of the alkenes, the fact that it can be represented by both of these structures means, and I don't love this representation, but it really is helpful here, we can think of benzene, pyridine molecules like this as being this, okay, where we can draw that circle to kind of show the resonance contribution of both of these two structures. What this makes it easier to see then is that there's a plane of symmetry that cuts through the molecule. And so the two hydrogens here, we could call both as HA. The two hydrogens here are both HB. So we would see one signal for the two HAs, one signal for the two HBs, and then of course we have the CH3. That would be the third signal. We would expect to see 3 signals for the hydrogens in this molecule because we have 3 sets of equivalent hydrogens.